Hello, welcome. We are going to look at line of a curve of intersection between a cone and a cylinder. And I have a question here that reads: the solids of two solids of a cone and a cylinder intersect as shown in the figure below. Draw the curve of intersection and a complete plan. As you can see from my figure, we have the cone having a diameter 60 and an intersecting cylinder that has a diameter 30 millimeters. So what we are going to do is to come up with this front itself, complete it by having our plan, and complete the front by having a curve of intersection, and then complete the plan by having all the details that will appear in the plan as you look at it at the combination from top. So let's proceed by having the given front elevation. We are going to have our baseline, out of which we can come up with a front elevation. So this is our baseline. Then we can measure our 60. Then our 30 is our radius. Then we can have our vertical line here. It will act as our center line. Then we can have the vertical height of our cone, which is 60 again. We complete. Now the intersecting cylinder is joining the cone at 20 millimeter. Its center line is 20 millimeter above the base. So we can have this center line here. Now the diameter for the intersecting cylinder is 30, so our radius is 15. That is 15. Then we can also again have another 15 here. Then we have these lines. Passing through now our extension, the cylinder is measuring 30 millimeter from here to here, so we can measure 30. This side and this other side. And then complete. So that's a combination of the cylinder and the cone. Let's draw our plan. The plan for our cone is a circle. So you can take the radius, have somewhere, let's say here, and we draw our plan. We can move it closer here. plan, which is a circle. We can project our intersecting cylinder to come up with our plan from this side. We can have this line, and then this other side again. Then we just measure the same radius from here up to here. We transfer here and here. Similarly, transfer here and here, and then we complete. We complete, and then we complete, and then we complete. The next thing we are going to do is we want to see the curve of intersection, and for the curve of intersection we need to have the plan, and the plan here we need to complete it by having the end elevation here that shows a circle, a semicircle of this intersecting cylinder, out of which you shall have lines coming down to intersect with this other side to give us both the plan and the curve of intersection. So what to do, we can have this radius and draw a semicircle here. Let's have that semicircle. Similarly, on this other side, let's have that semicircle. We can divide these semicircles in 6 equal parts each. That's how we divide. Starting here, we cut there. They come here, cut here, and cut here. And then come here, cut, and cut. The same radius, come here, cut, and come here, cut. Once you are through with that, we can still join. We are now going to number these divisions. We can start by 0, 1, 2, 3, 0, 1, 2, 3. When you come to the plan, if you look at this from top, okay, this is the top, and this one is like this is the, if you complete this circle, this one becomes the top. If they stop on the plan, it appears here, so it has to interchange. So that is 2, 1, 0, 2, 1, 0. We have to interchange. So next thing we are going to do, we are going to project lines from 0, 1, 2, 3 in that order back to our plan, and then similarly from this side to meet this line. How do we do it? We can use parallel lines. It's possible. We can have this. So that we bring the first one here, bring, let it stop there, come, bring this other one, let it stop there, come this other side from 2, let it come and stop here, lastly come for 1, let it come and stop there. Next, this one can still be done up here. We want to bring these lines, so we are starting with this. Again, we do the same with number 2. We bring that line to the end. We come to the next, number 1, bring that line to the end. Next is 1, sorry, it has moved. We can still realign, and then bring number 1 bring it to the end. Then lastly, bring number 2 to the end. Now what we are going to do again, you realize that when we want to draw the plan of an intersecting cylinder, this is how we trying to say that this is our cone and it is intersecting with a cylinder. The cylinder, when it intersects here, it will have to assume this shape. Okay, now if you look at it from top, if you observe the cylinder from top, you will be able to see this line from here. Let's assume this is our center line. Okay, this is our center line and we are saying this is 0, 0. So, and this is 3. So, if you look at it from this side, we are going to see this line because we have this. Okay, we shall see this line of intersection to the other side, and then this other part on the plan, we shall see it as a hidden detail because it is at the base of this extension, this intersecting cylinder. So we see that, and this one will be a hidden line. So now let's come back to our plan and we see how it's going to happen. Now what we are going to do is we are going to be drawing circles. Let's say the first circle here is circle number 3. So this circle number 3, we pick this radius with number 3 and come and draw a circle on our plan. That circle there intersects point 3, circle 3, point 3. So we put a dot here and we put a dot here. Next circle is circle number 2, and this is circle number 2. We come and draw circle number 2. Circle number 2. Circle number 2 again, we elongate this line number 2, elongate line number 2 to meet circle number 2. So this line should be elongated. Of course it should go to the other end, so we can still use this straight edge. Elongate number 2 to meet circle 2 and bring this again to the end. Also number 2 to meet line circle 2 and line 2 on this other side. So we can now say this is circle 2, 2, line 2, circle 2. We come to circle number 1, bring that and draw a circle. And draw a circle here, draw another one, that arc. Okay, may not be able to complete, it's not so necessary. So again, number 1 and 1. So I bring this number 1 to meet the circle. Of course it has to extend the other side. Again, let it go and then come and extend number 1 again to meet the circle there and extend. And this one we are calling it circle 1, line 1, circle 1, line 1. So this is circle 1, line 1, circle 1, line 1, circle 1, line 1. Next we are going to draw circle 0. Now we come and draw circle 0 here. this other side circle 0. Once we draw circle 0, we can look for point 0. Line 0, it comes. Here it is. You bring it to meet circle 0. Bring it to circle 0. Circle 0. This other side, bring line 0 to meet circle 0. Then again this side to meet. There it goes. Now circle 0 meet here, meet here, meet here, and meet here. If coming back to here, we have already gotten this line, which is an outline, as we said. This one is going to be appearing as a visible line. So we are going to join this with the outline up to here. Now let's see the hidden part. The hidden part, we start now from here. We start with another circle 1 here below 0. A new, so we come and pick this circle here. We can draw this way and draw this other side. Okay, now once we have that, that is circle 1. So we look for where 1 is. This is 1. We put a dot. This is 1. And this other side, the same thing. 1, 1. Next is circle 2. So we come and take circle 2 and draw the circle. Circle 2, circle 2. Circle 2, here it is. Look for point 2. This circle 2, okay? Then this is 2. And this other side, similarly, 2, 2. Then lastly, we have circle 3. We take this radius and draw circle 3. They are more of closer to each other. They might not be so close, but they are somehow close. Circle 3 and 3. So point 3 and circle 3 is here and here. So as we said, we are going to join an outline, visible line, from point 0 passing through here, back to here, going back to 0. Where is my 0? This is my 0. Then again, similarly, 0, 0. Okay, though this one has missed at some point. Next, we are going to draw the inner part, which is hidden. So we are saying this one is hidden. It is hidden according to our observation. Now again, this one is hidden. Once you have done this, we are going to draw the line of intersection. Line of intersection, or not line but curve of intersection, in our front elevation is the projection of this point, and this point. Okay, then again this point, this point, this point, and this point. How many points are this? 1, 2, 3, 4, 5, 6, 7. Same applies to this side. 1, 2, 3, 4, 5, 6, 7. Those are the points that are going to be projected up so that they give us a curve of intersection on our front elevation. So how do we project? We are going to use verticals, like For example, we can start with this side. Ensure you align your horizontal edge with this. We have the first one. Here it goes, it comes here. Second is this one. It goes, meets this one. Next, here it is. Come with it, draw. Next is this one here. You draw it. And then next is this one here. You draw it. Next is this one, okay. You come, pick it, draw it. Lastly is this one here, the inner one. You come and locate where it is. Here it is. And you draw. This one is somehow a bit challenging, but it has to come out. This one, the inner one, it's more closer. It's actually closer to, we have done this one, we have done this, we have done this, we are doing, of course we have done it. Okay, they are more of in the same line, eh? They are more of in the same line. They are appearing to be the same line. We can just have them drawn. This one and this one are appearing to be in the same line, but they cannot be. So we can just have it drawn by all means. Sorry, we can still complete up here. Okay, next we can come to this other side. We do the same thing that we did, saying the first one is this, the inner one. Okay, second one is this. Then next is this. We have done this, and now this. Next is this one. For this one to be drawn, you need to have a sharp pencil. Otherwise, you may end up drawing shading lines, and it's not advisable to shade. So we do that, and then we do this other one. Then lastly, complete this. Good. Now, once you have drawn this way, we are going to locate those points. Let's start with number 3. This is 3. We come and locate 3 is here. And then we come to 2. 2 is here, because this is 2. Then 1. 1 is here. Okay. Then 0. 0 is here. Then again 1. 1 is here. Then lastly, 2, not last but not least, least but not last, of course. This is 2. 2 is here. Then lastly, 3. 3 is here. So here is 3. Similarly, come to this other side. This is 3. 3 is here. This is 2. 2 is here. This is 1. 1 is here. This is 0. 0. 0 is here. This is 1. 2. Okay. This is 2. 2 is here. This one is 2. Okay, this is 1. 1 first. This one is 1. 1 is here. and then 2 is here. So this one should not confuse you. We can mark it. This is marked off. We are marking this off. Then lastly we mark 3. We are coming this other inner one. Here it is. So we are going to join those points with curve. These curves are what we are referring to as curves of intersection. So let's join. So once we join, we shall complete this other part, because we need to have the whole front, the whole plan. So this is how we join. You will realize that the plan is showing some parts visible, others are hidden. Like for example, this part is hidden because if you look at the cone from top, you will not be able to see the part that has been blocked by the extension, the intersecting cylinder, and that's why this part is hidden. We assume it is at the base of this projection, or this intersecting cylinder. So we expect it to be hidden on this side. We also expect it to be hidden in this side. This other line is hidden because it is below the intersecting cylinder. This other one, as we talked about it, from here all through 3 at the base, back here on the other side, from here all through the base up to the other side, it's hidden. And then this other top part from 0, this one and this one, it's going to be visible on our plan. Basically that's what we are supposed to do. Thank you very much for watching. Consider subscribing.